Let's look at this question. So a balanced three-phase circuit has the following characteristic. First is a YY connection like this, so simplest version, and the line voltage at the source. Okay, we know that this part is the source. Okay, and here is the load, and in the middle, load, and in the middle is the transmission line. Is a line. Okay, so at the source side, the line voltage VAB. So line voltage is line to line voltage. So the voltage across this A and B. Okay, so line voltage VAB is this value. Okay, in order to make the single line, okay, draw a single phase equivalent circuits, we need to know the VAN. Okay, in this one we assume there's no impedance in the source side, because if you rate the following, first the phase sequence is positive, and the line impedance for this one is 3 plus J 2, and for the load here is 37 plus J 28. So nothing mentioned about the source side impedance, so we are just assume there's nothing. Okay, so the next thing is we need to know the phase voltage. Okay, phase voltage VAN. Lowercase a is for this lowercase a. Okay, how to know phase voltage based on line voltage? First, we know is a positive sequence. This one is from the equation list for the exam. You're going to get this. So you will find VAB is the line voltage. So the line voltage VAB equals to that VAN, which is the phase voltage, divided by root 3, right? So this is smaller one. Okay, divided by root 3, and this one plus 30 degree. Okay, plus 30 degree. Okay, in other way, you can say that the phase voltage equals to the V line voltage no, so that's something wrong. So this one, you can see that this one's a smaller one, right? So this is a smaller one. So to make it, this is a shorter one. To make it a longer one, you need to multiply root 3. Okay, and you plot 30 degree. That's how you get this longer one, VAB, which is a line impedance. Okay, VAB. Okay, and this time, this VAN is the phase one is coming from the line impedance divided by root 3. So make it smaller in magnitude, and you need to minus 30 degree. All right, so the line impedance here is 100 and root 3. So for the phase voltage VA lowercase AN gonna equals to the line impedance divided by root 3. Okay, line impedance divided by root 3, and minus 30 degree. So 60 minus 30 degree. So what we got here is 110 and negative 90 degree. Okay, so that's the one. So after you got that, you can draw the equivalent impedance. So we have the voltage here, VAN, and there's a line impedance, there is a load impedance. Okay, and the line impedance is this one, the load impedance is this one. All right, so next is to calculate the line current in a phase. Right, for part B, line current is the IAA. Right, the line current is the current flow through the line here. Okay, in the YY connection, this IAA is also phase current because this is one phase. Okay, this is a line. Right, so IAA gonna equals to there is only one voltage source. There's two impedance, so we're gonna combine it. So to calculate the current here is very simple. It's just the VAN divided by Z equivalent. Okay, so VAN is 110 negative 90 degree. We just got that, and divided by the total impedance, 3 plus 37. That's 40 for the real part. And J here is 2 plus 28, that's 30 for the reactive part. Okay. All right, you can use the calculator to do this calculation, or you can do it manually. So the magnitude here, bottom, sorry if I write it like that, make it a phasor form for division. Okay, the magnitude is a 40 square plus 30 square and square root. Okay, that's magnitude. The phase is a arc tangent, B over A, which is 30 over 40. Okay, you can do that. If you use the calculator, you will find this one equals to 2.2 negative 126.87 degree. Okay, that's the current. And the next part is calculate the line voltage at the load in A phase. All right, at A phase, we know the phase current. If this is N, we know capital A N. All right, that's what we know. So for the third question, capital V A N, capital A N is the phase voltage across the load. We can just use IAA, the current multiplied with the Z load. Okay, so Z load is 37 plus J28, and current, we just got the current. Okay, so is the IAA multiplied with 37 plus J28, and if you use calculator, then you got this one is 102.0A and with negative 89.75 degree. Okay, separate this. Okay, so this is the voltage for this is voltage across the impedance, load impedance. That is the phase voltage, VAN, and this one's asking about this one asks about line voltage at the load. Okay, so VAB, we always use that. So VAB, line voltage, look at here. Line voltage equals to phase voltage multiplied with a √3 and a plus 30 degree, right? So we got this one multiplied with a √3. Whoops, sorry. So this one multiplied with √3, that gives you 176.81, and this one plus a 30 degree, that's negative 59.75 degree. All right. Okay, so for this type of question, you need to tell the difference between line voltage, like this is a line voltage across two line, and a phase voltage, which is one phase, and the equation is look like this. Okay, to convert between this for the positive sequence.